So today we're going to be talking about the product and quotient rules. The product and quotient rules are used obviously when I multiply for product and divide for quotients. I use these when I need to find the derivatives of any particular polynomials. And again, I use it when I multiply or when I divide. Now, yes, for some items it's going to be easier to actually multiply it out, and for other items it's sometimes easier to divide. But for right now, we're just going to follow the product and the quotient rules because that's what it says for us to do. So the first thing I'm going to do is I'm going to be using the product rule for derivatives. The product rule for derivatives says that I'm going to be using for finding the derivative. Now this item that is here, it's kind of hard to see. We haven't really used it before, and that's like right here, is actually saying that we're taking the derivative. So if I'm taking the derivative, it means that I'm taking the derivative of f times g with respect to x. With respect to x just means, and that's what the dx in the bottom means, that just means that I'm taking the derivative and x is the variable that I'm using. So the product rule says I take the derivative of the first thing that I'm multiplying times the second plus the first item times the derivative of the second. So that would be how you just do it. It doesn't matter if you switch those two pieces around as long as you are taking the derivative of one item times the second and then the other item times the derivative of the one you haven't multiplied before. So in the past, I've always known it as 1 prime 2 plus 2 prime 1, and the prime just means derivative. So if you want to memorize it that way, or if you want to do it the way this book particularly does it, that's fine. You're going to get the same answer since it's adding in between. So if I'm taking the derivative of this polynomial, I have x squared minus 2x plus 3 times x cubed minus 4. So what our book says to do is to take the derivative of the first item. So the first item is x squared minus 2x plus 3. So if I take the derivative of that, I would get 2x minus 2. And that would be the derivative of the first item, or f prime of x. Then I'm going to take the derivative of the second item, which is x cubed minus 4. When I take the derivative of x cubed minus 4, I'm going to get 3x squared. So that would be our g prime of x, since that's our second term. So that's 3x squared there. So then when I apply it to the product rule, I would have the derivative of the first. So the derivative of the first is 2x minus 2 times the second item, which was x cubed minus 4, plus the first term, which was x squared minus 2x plus 3, times the derivative of the second term, which is 3x squared. Then I'm going to multiply it all out. So I would distribute and FOIL here and multiply it out here. And then when I do that, I'm going to end up with this polynomial, which then I can find by adding the like terms, and that would give me my derivative. So this would be the derivative of f times g, or the multiplication of those two items. If I had actually just multiplied it out and then taken the derivative using the the power rule, I would end up with the same thing. But just sometimes it's easier to use it when it's with the product rule, and sometimes it's not. When you're in calculus next year, you'll figure out what's a better circumstance, but we're not going to worry about that right now. We're just going to use the product rule. So here's another one. It's a little bit longer. Notice that this time we're multiplying two trinomials. So when I'm multiplying two trinomials, I would take the derivative of the first, which is f of x, which would be 4x cubed minus 2x, which is right there. And then I would take the derivative of the second, which is our g of x. So the derivative of that would be 3x squared minus 1. So then I would use those two items when I use my product rule to actually find the derivative. So when I do that, I would use, there's my answer there. I would take the derivative of the first, which was 4x cubed minus 2x, times the second, which was x cubed minus x plus 1, plus the first, which was that, times the derivative of the second, which was 3x squared. Then I would have to multiply out here, I'd have to multiply out here, I'd have to add all my like terms, and then I would get the derivative, which is that. And remember, I can use derivatives for many different things, including velocity and the slope of a tangent line, as well as many more things, which you'll learn about next year. I can also take the derivative using the quotient rule. When I have a quotient rule, that means I'm dividing two things. So that's what that means here. And again, I'm doing it with respect to x, which means that my variable that I'm using is x. We didn't really talk much about differentiable. Differentiable is a particular mathematics term. You'll talk more about that, but basically it just means I can take the derivative And I know that g prime of x cannot equal 0 because then I would be dividing everything by 0. So the quotient rule says I take the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Now, the way that I learned it was low, that's an O, D high, less high, D low, over low squared. So low D high, less high D low, which just means I'm taking the bottom one times D high means the derivative of the top minus the top times the derivative of the bottom. So D low means the bottom over the bottom squared. So that was just the way that we memorized it. Whichever way you want to memorize it, you will need to memorize it. Find whichever way works for you, and you will memorize it for your next quiz. So here's an example of using a derivative using the quotient rule. So I'm going to take the top. So if our book again tells us to take the derivative of both of them. So if I take the derivative of 4x cubed, that would be 12x squared. So that's the derivative of f of x. Then I'm going to take the derivative of the bottom, which would be 2x, which would be like g of x if I'm taking things and putting them into my formula. So the numerator's f of x, and the denominator's g of x. Then I'm going to take those and substitute them into my quotient rule. So the quotient rule says I take the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. And then I would multiply these out, and I would end up with this particular term, which then I can combine like terms and get this. When I do that, notice that I could factor out a 4x squared. So if I take out a 4x squared, that would give me an x squared minus 6. I could certainly do that and leave that like that. The problem is that I can't cancel anything out anyways, so looking at that problem, I know that there's really no reason for me to factor because it doesn't get me anywhere. So if you wanted to leave it in factored form, you could certainly do that, or if you just want to leave it as is without having to factor it, that's fine. But you just have to make sure if it can be factored that you do factor and cross it out. Here's our next one, where I have, my f of x, which is my numerator, is x cubed minus 4, so the derivative of that would be 3x squared, and my denominator, which would be g of x, would be x squared plus 1, so the derivative of that would be 2x. So I'm going to take that and I'm going to substitute it into my quotient rule. So the quotient rule says I take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And again, then I would distribute all these things out. I would add like terms, and that would be my derivative. So these, as I said before, can be used for many different things. We're not going to use them very much because we've kind of run out of time. So we're just going to be finding the product and the quotient rules and just applying that. So when you come to class, we will certainly do more problems with these. Some will be a little bit more difficult. Some will be a little bit easier. But basically, we're just applying the formulas. So make sure you know them for the next time I see you. So good night.